do like the back half of the implicit differentiation. So this is the chain rule piece, where ln is your big and y to the third is your little. So I take the derivative of the big first. Well, the derivative of ln of x is 1 over x. So what's the derivative of ln of y to the third? Is 1 over y to the third. But then you took the derivative of a y. So you multiply by the derivative of that, which is 3y squared. Then the derivative of 5x is 5. You don't multiply by dy dx because you didn't take the derivative of a y there. And then the derivative of 3 is 0, so that just goes away. And we are trying to... Oh, I forgot my dy dx. Like, what are we trying to do? I took the derivative of a y, so I multiply by dy dx. And this stuff can simplify. That's just like 3 over y. There's 2 on top, 3 on the bottom. For the y's, you'll have 1 left on the bottom. 3 jumps on top. And then to get dy dx by itself here, if you divide by this, you're going to have like a fraction over a fraction, and that's a mess. I think I would rather multiply by the reciprocal. And then those cancel, and that would be your answer. Okay. What else? Yeah. 12. Okay, so we have a choice here. We can do quotient rule, or I could bring that up and do product. Do you care? Did you do it like a certain way? Or?
I started doing quotient and then I got confused.
You want to try product? Okay. Or I could like fix your confusion on the quotient. I don't care. Product. Okay. So I'm going to bring it up, and we're going to rewrite this on top, which I prefer. I would rather bring it up in almost every situation, because then I don't end up with a fraction over a fraction. So this is product rule with a chain rule involved. So big plus give. So this is my f, this is my g. So f prime is 1, and then I just rewrite g plus, and then give. So g prime. Well, g prime has a couple things going on. It's a chain rule. It's also, we're going to take the derivative of a y, so we're going to multiply by dy dx. Bring down the negative 1, reduce the power by 1, leave that sign of y inside, and then what do I multiply by? The derivative of the inside, which is cosine y, and then what do I multiply by? dy over dx, because I took the derivative of a y. And then the derivative of 5 is 0. That is not a friendly... Quotient was actually easier? That's the one we did yesterday, right? Yeah. I think it is, actually. Do you mind if I go through quotient then?
Yeah.
Okay. So sometimes you'll do that. Like, and this happens to me too. Like, I'll start a problem and be like, oh my god, I don't want to do it that way. And I'll try the other way. Sometimes the other way sucks too, but, you know.
Instead of having sin y to first, because like I did it when I turned it into x times cosecant of y.
You can do that too.
Alright.
Yeah, so I didn't think of that. So this would be the same problem, wouldn't it? The sine on the bottom and cosecant on top are the same, so you can do that. But I want to go through the quotient rule one also. So f prime times g, so 1 times sine of y minus g prime times f, so cosine of y times 1, all over the bottom squared. I made a mistake here. I'm gonna fix it. Sine of y squared equals 0. What did I forget? dy over dx. So I took the derivative of a thing with a y here, and I didn't put my dy dx. So there is a dy dx right here. And the reason that this turns out easier, in my opinion, is because you can this just doesn't matter. Basically, so if I multiply both sides by sine of y squared, on the left those cancel, and on the right you just get 0. So it's just sine of y minus cosine of y times dy dx equals 0. Should it where what? Yeah. Totally should. Okay, let's wait. So if I keep going from there, I would move this over, so it'll be negative on the other side, so I'll have negative x cosine y times dy over dx equals, it'll be negative sine y on the other side, and then divide by negative x cos y. And then you could cancel those negatives too, actually, but you don't even have to. Or, I could say that is 1 over, so tan of y over x. So the negatives cancel. Sine of y over cosine of y is tan of y, and then the x stays on the bottom. Like, I don't care about that. You can leave it here. But on the multiple choice, they might have put this, and you got to be able to match up. Does he have a second? Part of your head was up? 10? So I would prefer to think of this as, I think it's easier for most people, as like 1/2 y instead of y over 2. I just think it's easier to see. Like some people I've seen try to do quotient rule to take the derivative of this, but that's like way extra. It's really just 1/2 y, then the derivative of 1/2 y is just 1/2. So I don't know if that was part of the issue or not, but that's a thing I see a lot. So I'll take the derivative. So this is the chain rule. Derivative of the outside is cosine. I leave the inside alone. And then I multiply by the derivative of the inside. So what's the derivative of 1/2 y? 1/2 times dy dx. Plus the derivative of e to the y is e to the y times the derivative of the power. That's like it's not really chain rule, but it kind of is. What's the derivative of y? It's 1, but then it's dy dx. And then the derivative of 4x is 4. That part okay? So both of those things have dy dx. I might multiply everything by 2 right now. Why would I do that? What's the benefit of that? Yeah, fractions suck, right? So if I multiply this piece by 2, that just goes away. So I'll have that. If I multiply this piece by 2, now it's 2 dy dx. And then don't forget to multiply that side also. 8. Okay. And then I'm going to factor out a dy dx. And I'm going to try to shortcut this. If that's too much, let me know. But that 8 is on top on the other side. If I factor out a dy dx, that stuff is what's left, right? In the parentheses. So where's it going to end up? I'm going to divide by it, so it's going to end up on the bottom. So here I'm going to have cosine of 1/2 y plus 2e to the y. So if I were to write that stuff instead out, I'd have dy dx pulled out cosine of 1/2 y plus 2e to the y. And then I would divide by all that stuff to make it cancel, and it ends up on the bottom of the answer. Carter, how's that? Fine. Not good, just fine. Depends how you say fine. I'm just like, I'm still chewing on that. Fine and good are the same thing. It's like how my first year was not always doing it. Fine. That doesn't mean that. What else? Yeah, we're going to do that, yeah. What else? Anything else? 13? They got a blank screen. So I put this times here, which I think helps. It wasn't in the original problem. But one thing I can very easily see is people not remembering that this is a product rule. Because you have like a function times another function. So there is product rule. And then in the product rule, when I go to do the derivative of this piece, I'm going to have to do chain rule and the dy dx. So f prime times g. So f prime is 1 over x times g, so e to the 3y. That's the derivative of the first thing, times just leave the second thing as it is. And then gif, so the derivative of g, so the derivative of e to the blah is e to the blah, times the derivative of the blah, which is 3. Then we took the derivative of a y, so we multiply it by dy over dx. And that's my g prime times f, which is ln of x. So that whole piece of trash is my product rule. And then over here, this will be 4y and then times dy dx. That's a pretty tough first step. You got ln's, you got e's, you got product rule, chain rule. A lot going on there. Is that first step okay? So then I noticed that this has a dy dx in it, and so does this. So I'm going to move over there this time. And I'm going to rewrite this as e to the 3y over x. And then over here I'll have 4y times dy dx minus, and you can leave this in that order. To me that just looks ugly. It's like an OCD thing for me. You can leave it, but I'm going to rewrite it. Put the number in front and the dy dx at the end. But again, that's just my personal preference. You don't have to do it that way. Okay, so now what? Factor out the dy dx. I do want to talk about the last step here. So I'll have dy dx on the outside. And then 4y minus 3e to all that stuff. 3e to the 3y times ln of x. So when you divide this, I just want to make sure we all understand. If I had 2 over 3 equals 4x, isn't multiplying by 1/4 the same as dividing by 4? So you could divide that by 4. But the way most people do that, you kind of get stuck in, not some of you guys, but that's like a fraction over a fraction, and that just gets messy. So instead I'm going to multiply by the reciprocal. And then for most people, figuring out that is a lot easier. So this is a weird thing to multiply by the reciprocal, because it's just a heap of garbage, but you can still do it. So I'm gonna multiply by 1 over all that crap, which will make it cancel here. And then it just ends up on the bottom over here, because you'll have 1 over blah, blah, blah. So the top will be e to the 3y, and the bottom will be x, but then times all that stuff. Otherwise, you get a fraction over a fraction. That's just messy. How's that, Kurt? Or anybody? Was it the last part that was? Yeah, no, that's a fair question. All right, let's start looking at I want to go back to the notes. And I'm going to do 3, 4, and 5 with you. There's a word in that question which is something you probably don't want to see. It's the word all. Equation of all tangent lines. So there are multiples. And that picture is there just so you can kind of see that. So x is 1 is around there. But in a circle, there's 2 times when x equals 1. So we're going to have one tangent up there and another tangent down there. So there should be 2 answers to this. Yeah, like they're just going to be reflected, but I still need that too. So if I go through this, equation of the tangent. All right, so let me do that over here. So I'll start my equation of the tangent line. I'll pretend I don't know yet that there's going to be 2, and I'll just leave that. X equals 1 goes right there. They didn't give me a y value, but they did give me enough information to find the y value. What do? I just plug in 1, right? So if I plug 1 into this, then the only variable left is the y that I can solve for. Sometimes they give you the coordinate, they'll give you both. Then you don't have to worry about plugging in, but usually I see them, they want you to plug in. So this will be y squared equals 3. And this is where your all comes from. So this is plus or minus root 3 are your 2 y values. So like this is 1 comma root 3, and this is 1 comma negative root 3. So now I have 2 tangent lines, root 3, negative root 3 for my y values. Good there? So what do I need to do to find that slot? Take the derivative because derivative is slope. So that's going to be 2x plus, bring that down, you'll have 2y, and then times dy dx equals the derivative of 4 is 0. And we're trying to solve for dy dx, right? So I would like move the 2x over. 2y times dy dx equals negative 2x. And then divide by this 2y. And ordinarily, I would just leave that as like negative 2x over 2y. But I have to do something with it. Like I have to plug in. So it's probably easier if I get rid of it and just write this as negative x over y. And then these are my slopes, and I have 2 points. This was at 1 comma root 3. This was at 1 comma negative root 3. And I'm going to plug in the x and y values. That's the difference in these. You're plugging out x and a y instead of just 1. So if I plug in, that's my x and that's my y, I'm going to get negative 1 over root 3. Right? You are allowed to leave it that way. You do not have to simplify it to get rid of the radical. And if I do that same thing for the other one, well, this goes through 1 comma negative root 3. So it'll be negative 1 over negative root 3. So they don't all have 2. Like I don't know if there's any that have 2 in your work, but it's fine to go through one. The process is the same though. You plug in to find, make sure you have the x and y, take the derivative and plug in to find your slope. How's that one for 3? Question up? Okay, erase it or can you still, oh, you still write? You good? Alright, let's do 4. Oh, we got a little note box there. Horizontal tangent lines. Be careful how you abbreviate horizontal. What's the slope of a horizontal tangent line? 0. So if you have a fraction, it's 0 over like who gives a crap, right? Because 0 over anything is 0. Unless the bottom is 0, but that's not going to come up. Vertical tangent lines. What's the slope of a vertical line? Slope is undefined, which means where's the 0? It's on the bottom. So you're going to end up with a fraction when you take this derivative. And to find horizontal tangent lines, we're going to set the top equal to 0. And then to find vertical tangent lines, we would set the bottom equal to 0. So it just depends which one they have. Number 4 asks for horizontal. Squared plus 2y squared equals 16. They don't give me a point because that's my job to find the point. Well, it's my Take the derivatives of 6x plus, this will be 4y times dy dx, and then equals 0. And then I would subtract 6x. Divide by 4y. That's not how algebra works. Divide by negative 6x. I don't know what just happened. 4y times dy dx equals negative 6x. Okay, divide by 4y. And we don't really have to work with it, so it's okay if you don't reduce it. You could, though. But I'm just going to leave it like that. And then this gets a little weird. My job is to find horizontal tangent lines in number 4. So I'm going to set which equal to 0, top and bottom. So the top equal to 0. So I will get negative 6x equals 0. And if I solve that, I get x equals 0. Well, my job is to find horizontal tangent lines. Is that a horizontal line? X equals 0. That's a vertical line. Like if all your x lines are the same, like 2, 3, 2, 7, 2, whatever, it's 2, and then that's a vertical line. If all your x lines are the same. So that is the x value of the point on the graph where there is a horizontal tangent line. But what does the equation of a horizontal line look like? It's y equals the number. This is actually what we're doing in algebra. So we just found this vertical x equals, but they're asking horizontal. So we need to find the y then, because that'll tell us y equals 1. So what do I do with that x equals 0 to find the y? Plug it back in. So that just becomes 0 basically. Those go away. I would divide by 2. And then square root. How many answers am I going to have? I'm going to have 2. And those are horizontal lines. Y equals a number is a horizontal line. The slope is 0. So that's a little weird because like you feel like you solved it, you get to the x, but that's not actually the answer. No. I would actually prefer that you don't, because you might screw up. Not you personally. How'd that go? 4 okay? Questions for me? We need to practice. Let's do 5 because it's fairly similar, just opposite. 5's asking for vertical tangent lines. Oh, it's the same freaking equation. So the derivative was negative 6x over 4y. We kind of already know the answer. And if I'm looking for vertical tangent, no, we don't know the answer. If I'm looking for vertical tangent lines, do I want to set the top equal 0 or the bottom? Bottom. So 4y equals 0. Divide by 4. That'll give me y equals 0. But my job is to find vertical tangent lines. That is horizontal line, right? Y equals number is horizontal. So I gotta find the x value that goes with it. So I gotta go back to my original equation. Plug in 0 for y. And solve for x. So you'll get like x equals plus or minus root 16 over 3. And I know you can pull the 4 out on top, but you don't have to. But again, you solve it. We're looking for vertical tangent lines. When you solve it, you get horizontal. But that's not what we want. So you got to plug that back in to find the vertical. And sometimes when you solve it, it'll be what you want. Like sometimes you'll solve this, and you'll get x equals 7, and that's a vertical line, and you're just done. But you just got to make sure. If they're asking for vertical, it's got to be x equals horizontal, it's got to be y. Questions on that one, or like I'm kind of done, so that one or anything? so you try. So you're going up through. All of it, up through 22. Eh, 21 is kind of ridiculous. You don't have to do 21. When in doubt, beat out. So look at x equals 1. Tell me if the slope of the tangent line is positive or negative. Negative, so can you see, right? So I can tell already it's A or B. No, that's right. I think it's right. But I'm not worried about that. So we did it all wrong. Please let me know if I can help. I won't be here tomorrow. So I'm gonna leave you like a review of stuff we've done, and then we have some more units. So your test probably won't be till like early the next week. It looks like. I got there at school on Wednesday. Can it? I think the stats will be Friday. I think that'll probably happen. But then remember the contest is 3 days long. This is tomorrow. You good? You got it? Big. You're not gonna be here? So we can do that. The probably will. Where do you want more? Oh, you just come like this class. You do it here. That's not it. So I can give it to Brown. Yeah, don't come tomorrow for me. Or I'll try to put on school with you too. It might just be con. I gotta see how the con. Sometimes they go a little crazy and work a little well. Sometimes not. Maybe I can finish it now. Well, I gotta do it anyways, so I'd rather have it done.